Hello and good morning, good afternoon to everyone out there. Welcome to our technology webinar. Today we're going to pleased to have Jimmy Lin, my esteemed head of product management, join. And he's really going to be the one that walks through what we do uniquely to detect and ultimately block the multiple numbers of targeted phishing attacks, social engineering, what we call human hacking attacks. So what we thought we would do today is really dive into the technology and what makes it unique. And as this really to kick this off, how AI stops multi-channel phishing. And the reason why we want to talk about this is that we're really of the belief now that the only way you can stop the significant number of targeted phishing attacks, smishing attacks, vishing, whaling, and number of what we would call that human element, human interaction attack. The only way you can stop these attacks is using deep AI models to really scour the web, find what those scams, find those threats, and be able to do that really in real time. And as Jimmy will highlight here, the reason why you want to do that in real time is because if you don't find them within the first 24 hours, 48 hours, they die and they move to the next one. So why you want to be able to use AI to find those in real time and then propagate that down to where the users interact with these threats, which is on the end device. And so again, today we're going to go in depth on the technology and how you can use AI to really stop these very significant number of attacks. And again, I'm commonly asked, why do you want to focus on phishing? Phishing has been old. And Jimmy, if you want to move to the next slide, I think we're going to get into again the threat landscape. But why do you want to stop these phishing attacks? Why is it important? In many respects, phishing is as old as computing. And in fact, I think when emails were launched and became the most popular app or the killer app on the internet, the bad actors first, they realized that there was ways to scam and co-opt users, both on the corporate side as well as on the personal side. And that's the reason why you started seeing, hey, send me your, I've got a great deal for you. Put in your credentials, and that's all you need to, or try to do something to get you to do something. And again, that's very old. The real challenge, I would say, is that this model, the model, the sophistication, and the techniques these bad actors are using has not just significantly evolved, but it's exponentially evolved to one of being very, very difficult, very, in fact, not even discernible to the naked eye to be able to find these attacks. And not only not find these attacks, prevent those attacks from happening. And again, I was saying, why is this important? If you look at a number of studies out there, and Jimmy's going to go through further detail, the one thing that really keeps me up at night is if you dissect all the popular ransomware attacks out there, they all started with one thing, and they started with that phishing, that human element. The reason for that, humans are infallible. They're kind of the weakest link in security, particularly as we've gone remote, working remote everywhere. That users become the new perimeter. They're on the same device, doing personal and business together at the same, not even just in the same hour, in the same 15 minutes. It's not uncommon. We're all guilty of this. We're on this PC. Next thing you know, we get a text, we get distracted. Well, those bad actors know about it. And so what we've seen from an evolution perspective is not only that the sophistication of these attacks is just dramatically grown, but also where these attacks are coming from. As I mentioned, email was the predominant channel that these bad actors would deliver these threats. But that's no longer the case, where what we see, and we have a very significant lab, we see these attacks coming from all communication channels. So what I mean by communication channel, this is really how we do our day jobs. This is how we do our personal life. And those communication channels on our job wise can be certainly, yes, Office 3 or Microsoft 365, Google Workspace, but I also use Slack. I use Teams, I use Zoom, which is what we're on right now. I use SharePoint, I use Box, I use Dropbox. There's n number of tools I use on a day-to-day communication basis as a team, a collaboration effort to get my job done. Well, that has opened up new avenues for these bad actors to deliver these threats. And believe me, they are doing that. But it doesn't stop there. they're also delivering these threats through all your popular personal communication channels. And again, why is that important? So we have seen just a dramatic increase in the number of LinkedIn attacks. So LinkedIn is obviously popular. We all use it. And I think LinkedIn got broken into 9 months ago, a year ago. And they're obviously we're able to do a very large download, data dump download. So effectively, these bad actors have full visibility of who you are, who works for you, where you've been. So they have a pretty interesting insight to you as a user. So that's the reason why we've seen a large number of increases of attacks there. And those attacks may start in LinkedIn, and then they do what's called a lateral movement or a crossover attack. So they move into the corporate side. And again, that's just one example of that. SMS has become another popular communication channel to attack you, both on the corporate side. We've seen the call this 800 number, or more importantly, we see call your IT department immediately because your account got compromised. What are you going to do? How are you going to prevent that user from being scammed once they get them on the phone? Very difficult to stop. And there's n number of videos you can go watch out on YouTube about how the bad actors are able to get someone to give up their username and password once they get them on a phone. So again, multiple examples, and I could go through WhatsApp, Signal, and number of these personal communication channels. And the reason why this is important, and you may ask, so don't worry about that. Well, these are crossover or lateral attacks that do come back to affect the corporation, and that's why you need to pay attention. I was just talking to a CISO of a very large company, and someone impersonated the CEO on WhatsApp and actually sent a note out to the financial community, to their financial players. Again, they had all the LinkedIn profiles, asked them to invite them on a Teams meeting. Believe it or not, a fair number of them joined. And in that context, they had a talking head. They had actually co-opted from a CNBC video of the CEO. But as we've all been on the Zoom and Teams meeting, when it said, hey, you have to turn it off mute. Well, they said, I can't get the audio to work. And in chat, asked them to give some financial information. So that's just one example of several out there of the type of scams that are happening on those personal communication channels that do those lateral attacks or crossover attacks. Bottom line, this is a very sophisticated, evolving threat landscape. And as we have seen, it truly is now the number one cybersecurity problem, because it leads to all things evil, as I like to say. It starts with that phishing. It starts with that social engineering attacks. It starts with that scam. It starts with that rogue browser extension. It starts with the Bitcoin scam that the 14-year-old used to take down Twitter. So it all starts with that human element, that human interaction, that then leads to ransomware, it then leads to data theft, it then leads to financial fraud. This is kind of one popular quote I like to take from Gartner. 95% of all successful breaches that happen in the enterprise or the business side start with a phish or human element. So think about that for a moment, and think about that as we're going through this, the rest of this presentation. So Jimmy, I'm actually going to let you walk through the other trends that you're seeing, and then get deep into the technology.
Great, thanks, Patrick, and thank you everyone for joining today's webinar. So I'll start this conversation by sharing a couple of observations and data points by SlashNext's Threat Labs and also external parties. I think all the participants on this call are aware phishing is and has been for many years as the #1 threat action to breach organizations. Phishing, however, was never isolated to email. It was always multi-channel problem. We're noticing it more now because attacks are increasingly being delivered via social media, collaboration platforms, and other channels. Now, there are many reasons for this, including the fact that those channels are often less protected than emails. So a couple of observations. So Google's threat analysis group published an article last month warning the security community that they are observing attackers driving targets to messaging apps. The initial contact may be established via email to build cadence, to build that trust, but the call to action is to join a chat group on the likes of WhatsApp, Discord, and Telegram, where the phishing payload is ultimately delivered. And their educated guess for this trend is that the other channels are less protected. than email, right? Gartner released their market guide for email security in October, and they share a very similar message. They noted that with the shift to remote and hybrid working, communications between your employees and external parties is moving beyond email to LinkedIn, to these other communication channels. And we know, multi-channel phishing is a big problem when Gartners recommend email security buyers about the need to protect non-email communication channels. The only thing I disagree with Gartner on in that paper is when they said, these channels have the potential to be used by attackers for phishing distribution. And the reason why is because attacks delivered via LinkedIn, WhatsApp are taking place right now. According to Verizon's Mobile Security Index report, 85% of the attacks against mobile device users, for example, takes place outside of email, right? And that's not surprising because in the same report, organizations surveyed, 70% say they didn't have any protection for their mobile devices. Now, attackers are obviously opportunistic. They're going to go after the soft targets, right? Devices and channels that are least protected. The remaining 2 data points are not multi-channel data points per se, but I think they're very informative. Our Threat Labs team released our annual human hacking report last month. And we found that credential stealing attacks with the most pervasive type of phishing threats, followed by social engineering scams. And we all know that stolen credentials, are sold on the dark web and used to conduct additional phishing campaigns. But I always wonder, how they are associated with the other type of breaches and to what extent. So in Verizon's most recent data breach investigation report, DBIR, out of the organizations that they surveyed that suffered from ransomware-related breaches, they found that 60% of the cases involved direct installation of the ransomware using the stolen credentials, right? So when we stop credential stealing phishing attacks, we reduce the risk of ransomware-related breaches by 60%, if my math is right. So to summarize, phishing is a big multi-channel problem and a growing problem in this new remote and hybrid working world. And phishing, as Patrick has already said, is the root cause of all evil. It leads to ransomware breaches, data exfil, and brand damage. So, what has kind of changed over the last 2 years? Obviously with the pandemic, bars and entertainment venues were closed. So users and employees are definitely consuming more digital content, right? And these contents are consumed through endless number of channels, some less protected than others, if there are any protection at all. And some of us would argue, as security practitioners, that with the shift to remote working, employees have become less risk averse, right? They would click on links or browse to websites that they normally won't. And of course, working from home, naturally, it comes from the distraction, especially you have young children and pets like I do. So the blending of work and personal life, on unprotected channels creates new risks for organizations. And hackers, of course, are opportunistic and are taking advantage of this trend, delivering phishing payloads via channels that are least protected. And this, again, was supported by the observation that was made by Google's threat analysis group. Hackers, as you guys all know, are constantly evolving as well to bypass detection, to improve their success rate, right? After all, 95% of the attacks are financially motivated, according to the same paper from Verizon. So there are a number of evasive techniques that attackers or hackers use to prevent security vendors from preemptively classifying their phishing web pages as malicious. SlashNext's Threat Labs found 12% of all phishing web pages in 2021 are hosted on legitimate cloud infrastructure, such as SharePoint and Box. And the reason why is to bypass domain reputation-based technologies, right? That looks at when a domain was registered, if a domain was registered within this last 7 days, mark it as bad. So by hosting your phishing payload on the likes of SharePoint and other platforms like it, it prevents the web pages from being classified as malicious. Attackers are also increasingly using CAPTCHA inspection blocking by IP, essentially to prevent their web pages from being preemptively analyzed by security solutions. Now, on top of that, the setup, the distribution of the phishing web pages, and the deployment of these defensive techniques are all done using automation, right? So signature-based detection solutions will always be one step behind. So what I want to do now is I want to just kind of talk about the common detection technologies that we see across secure email gateway solutions, proxies, and endpoint solutions, right? And explain why it's not sufficient to protect users against today's multi-channel phishing attacks. And then I'll go over our AI, cloud, and on-device technology. So I should say, prior to joining SlashNext, I spent about 16 years at Symantec working on their advanced threat protection offering for email. So I know enough about SMTP and phishing to be dangerous. So if I look back, over the last couple of years, improvements to detection technologies for malware has been fairly steady, right? It went from signatures to heuristics to sandbox to isolation. Detection technologies for phishing web pages and social engineering web pages haven't really changed much over the last couple of years, right? And most of the technologies rely on domain reputation. And again, if an email contains a URL, right, where the host was registered within the last 7 days, I'm gonna stop that email. Or when a user attempts to request for a website that is on a host that was created over the last 2 weeks, I'm gonna block that request. And that is all fine. But again, 12% of the phishing pages are hosted on the likes of SharePoint, Dropbox, OneDrive, right? So relying on domain reputation analysis is not going to protect users from those type of spear phishing attacks. Phishing kit HTML signatures. So what I mean by that is, one of the reasons why phishing attacks are so pervasive is that the attackers don't need to be technical, right? They can purchase these phishing kits and set up phishing campaigns en masse. So to counter that, threat researchers, right, the good guys, they also download these phishing kits, create phishing web pages from them, and then try to find out if there are any fingerprints left by these phishing kits. And that's how they use to detect phishing web pages, because they can tie that web page back to the specific phishing kit that was used to create them. The problem with this approach is that it's a race condition, right? In order for you to successfully stop these phishing attacks, the good guys have to know a new phishing kit has been released, go through the process of creating the web pages, create the detection for it, and deploy the detection, right? And that process is time consuming. So again, you're always playing whack-a-mole when you're using HTML-based signatures. Image matching. So in the market guide that Gartner released in 2020, for the very first time, they recommend you seek email security vendors that leverages computer vision ML to help protect against spear phishing attacks. And since then, there has been a number of vendors that start adding computer vision ML to the data sheets. And when we dig deeper into it, what we have learned is that their machine learning is really rudimentary. Essentially, what it is doing is the equivalent of image matching. So what they do is essentially look at a web page that has been confirmed as phishing and essentially take a snapshot of that web page. So when a user requests for a URL, or if a URL is delivered via email, for example, they will essentially compare the two images. If they're identical, then clearly that particular message or the URL is phishing, right? So again, this is a signature, right? You are relying on a known website, creating an image or signature out of it, and then use that to determine if the new URLs are phishing or not. User URL rewriting, sandboxing, these are not detection techniques. They're either features of a product or product themselves. And if you're using advanced threat protection offering, it obviously comes with URL rewriting and sandboxing. And people believe that they are sufficient against spear phishing attacks. And that's not really the case. What URL rewriting is doing is simply giving your email security vendor another opportunity to check at the time of click if the URL now exists in the database, right? They're not doing anything more than that. And sandboxing, that's a common misconception. With sandboxing, essentially what it is simulating binary payloads like executable files on an OS, right? But if a URL leads to a phishing web page, there are no binary files to detonate. So sandboxing does not help protect users against spear phishing attacks. And lastly, with email and browser isolation, email isolation is what I call selective isolation. You isolate the web pages that do not have a long history of being good. So the problem with this approach is, again, if the URL is hosted on SharePoint.com, that's owned by Microsoft, right? Those phishing web pages will never get isolated. And again, the users themselves can fall prey to the credential stealing attacks. So signature-based detection, can't keep up with today's threats. And, isolation is not the solution in combating spear phishing attacks. AI and machine learning in the cloud and on device is a must to protect your remote employees from multi-channel spear phishing attacks. So what I want to do now is go through the technology in depth, explaining how we do it, on the cloud level, and then how we do it on the device level. So SlashNext was founded, because a new approach was required. Our founder, Atif Mushtaq, and his team built a patented AI detection system back in 2016 that uses virtual browsers and machine learning. On a high level, this patented AI detection engine consists of 3 layers, if you will. Big data to give us visibility into all internet traffic, virtual browsers to render the web pages for analysis, and then finally machine learning classifiers to perform the analysis of web pages to identify zero-hour phishing attacks. So starting from the bottom, threat sourcing, threat cloud. We start with visibility. We source information, from multiple sources such as passive DNS, ad networks, smishing traps, and certificate logs, just to name a few. With passive DNS, anytime a new domain is registered or a web page is activated, we gain visibility into that. Now, what makes our sources unique is that, one, they're very diverse because we're not focused on just the email vector. We're focused on multi-channel protection. So we have smishing traps in addition to spam traps, for example. Secondly, our visibility is very significant. We were engaged by a $35 billion cybersecurity company by market cap to help them improve their efficacy for phishing protection. And in that engagement, we found that we analyzed about 7 times as many newly registered domains as they do. Yeah. Now, with that said, I think all the participants know, visibility is meaningless if you cannot tell the difference between phishing web pages from the good ones and vice versa. And that is the SlashNext strength. Our strength is our capability to identify phishing web pages from this big data hours, sometimes 2 days ahead of the other vendors. And how do we do that? So one of the secrets is the use of virtual browsers. Now, if you think about it, phishing web pages, unlike malware, do not attempt to hide itself. The opposite is true. You want to make sure the web page is rendered correctly and looks identical to the web page that's trying to impersonate. So our fundamental belief is that before any analysis is done on a web page, we must be able to see, if you will, the web page as it is intended to be presented to the user target. Our virtual browsers basically allow us to achieve this. So before any analysis is done against a URL, what we do is we load the URL into our virtual browsers, letting the image, text, and other content fully render. No different than if you were viewing a web page in your Chrome browser, for example. The use of virtual browsers also give us another advantage. It allows us to overcome evasive techniques that we talk about, such as inspection blocking using CAPTCHAs, that allows us to get to the actual attack page and perform the analysis. Now, once we see the content, so I'm in the AI threat analysis box now. Once we see the web page content, we then begin applying our machine learning classifiers. Now, the reason why we have different machine learning classifiers, Roadware, Zscaler, is that you cannot have ML trained, for both credential stealing and social engineering scam and be effective for both at the same time. And the reason why is because the phishing payload, the phishing web page are very different, right? So social engineering scams, to elaborate, are web pages that promises a reward by entering personal information, right? If you fill out this COVID survey, you get a $50 gift certificate. Now, the reason why you should care to protect your users against social engineering scam attacks is that the stolen personal information is then used for targeted research, right? By looking up or using the likes of LinkedIn, Facebook, find out what their interests are, who their network connections are. That then leads to targeted credential stealing attacks. And again, those attacks can't be delivered via email, but we're observing a significant increase in the delivery of those attacks via LinkedIn messaging, chat, and SMS. So again, multi-channel protection, in addition to have the ability to protect your users from spear phishing attacks is absolutely critical. There's another type of classifier I just kind of want to point out when we're on this subject. We also have classifiers for what we call roadware. So these are web pages that essentially leads to the download of exploits, Trojans, as well as ransomware and browser extension, right? So if you are using a EDR solution, and I trust that many of you are on your endpoints, that's going to detect the suspicious behavior after the fact, right? After the malicious payload has already been downloaded onto the endpoint. With our solution, we stop the attack much further up the kill chain by preventing the user from accessing the web page that contains the download, okay? Now, this process that I've just described, where we take the URLs from our sources, spin it up in our virtual browsers, and then apply the machine learning classifiers, this is done 24/7. And you can imagine the AI workload is very, very intense. So we have our own computing farm that consists of, I think by now, at least 20,000 core CPUs and GPUs. And we're closing in, about 2 petabytes of data. Because at the end of the day, in order for your machine learning to be effective, you have to have data, you have to have good data. Without it, your machine learning is no good as signature-based detection. So at the end of the day, what we're able to provide is essentially the world's largest and most accurate intelligence database on phishing URLs. Our detection rate for phishing attacks is 99.9%, and our accuracy will only introduce about 1 in 1 million false positives, right? And this has been vetted by external technology partners and cybersecurity vendors as well. So as Patrick had mentioned at the very beginning, this large database of zero-hour phishing URLs are then consumed by our products to provide the first layer of defense. Because if you think about it, having a database of phishing URLs, isn't going to protect you perfectly against spear phishing or targeted attacks, right? Because there's always a scenario where a URL was created specifically to be distributed to your CEO or another VIP user. And that URL may have never made it into any vendor's security intelligence. So how do you protect a user against a targeted attack like that? So what we have done is essentially taking the machine learning capabilities in our AI threat cloud and also ported them into our endpoint products. So we have a mobile protection solution for iOS and Android devices. And this mobile protection provides app protection, meaning that regardless of which app that you're using, if you're clicking on a link from your Outlook app or your LinkedIn app, the mobile device will analyze that particular URL and block the user from accessing it. In addition to that, smishing is a very big problem and has grown significantly. And our mobile protection is very unique. We have the ability to protect users against what we call natural language attacks. These are phishing attacks delivered through SMS, where there's no link. The call to action is for you to reply back, right, with your personal information or for you to call a phone number. So the natural language processing ML within our mobile app essentially analyzes the text in the SMS in real time to understand the intent and tone and protect the user against those type of attacks. We also have a browser protection solution as well. And the form factor for this solution is a browser extension. And it also has machine learning built into it as a second layer of defense to protect employees from targeted attacks. And the way that this works is very unique. Essentially, for any web page that is unknown to us, meaning that it's not listed in this intelligence database, what we will do is we'll scan the browser canvas in real time to determine if the web page is benign or phishing and block the attack before the users even get the opportunity to enter their credentials. So what I want to do now is just kind of a quick demo of our intelligence. As I mentioned earlier, we identify newly created phishing URLs anywhere between 2 hours to 2 days before the competition. So what I'm going to do is I'm just going to log into my intelligence portal. And in here, what you can see are essentially some of the latest URLs that we have uncovered. And this time here, by the way, is in UTC. So if you're in New York, this URL was uncovered around 1:11 p.m. And let's just kind of take a quick look at this particular web page. So this web page is hosted on OneDrive.com, and clearly it is an attack where if you were to click on View PDF, it basically takes you to a credential harvesting website. So what I'm going to do is I'm just going to copy this URL, and I'm going to bring it over to VirusTotal and just kind of run a check here. So on VirusTotal, you obviously, it differs every day, but today you have 93 security vendors listed on here, right? So this URL, we uncovered it at 1:11 p.m. Now it's 1:37, 20 minutes ago. and none of the 93 AV vendors on VirusTotal has picked it up as phishing. Now, for those that are using Zscaler as your web security service, let's take a quick look at what verdict they come back with. Based on my past experience, Zscaler typically catches maybe one of every 10 URLs that's already known to us. So let's see what happens here. And this is unfortunately a little bit slow. They're still processing. So the reason why it took a long time to process is that clearly Zscaler don't have this URL in their database, right? So they're performing the analysis live using their own technologies. So that's why it took about, 30, 45 seconds. But you can see that test results came back as benign. And one of the very interesting things is, let me see if I have it, is what you'll notice is that Zscaler actually have a -15 score here and a -10 score here. And what this means is, my interpretation of it is that because this is OneDrive, the certificate is valid, it belongs to Microsoft, and therefore it actually gets a good score. So the -15 is actually, this is not just a benign website, but we actually think that this is a good website, right?
Hey, Jimmy,
So,
this kind of goes to the heart of what you were talking about a little bit ago, and this is one of the massive changes that has occurred or used by the bad actors. They are using the exact legitimate hosted infrastructure that everyone else out there uses, whether that be AWS, Azure, Canva, Adobe, really trusted domains and reputation scores, which is why, as you see in that Zscaler case, they're tuned just to let all that stuff through. And bottom line is it fair to say, unless you're doing that deep analysis using the virtual browsers, there's really no other way to actually at runtime figure out, is it a threat or not? Is that fair?
yeah, that's exactly right. Because, the attackers know about, again, 95% of them are financially motivated, right? So just like we have research teams, they also have intelligence research teams. They learn about how detection technologies work. So one way to get around the detection technologies is, again, to host it on the likes of OneDrive, SharePoint, but also compromise websites as well, right? Because those are not throwaway domains. Those typically have good or neutral reputation. So there is a need to, for phishing attacks, you cannot rely on when the domain was registered, if the URL contains the word Microsoft or spelling similar to it. You have to analyze the content in real time, and you have to analyze that content using machine learning, right? Because these phishing web pages, again, are set up automatically using automation, using AI. So if your security solution is heavily signature-based, they're not going to be able to protect you from the spear of the attack, right? So what I want to do now, team, is before I hand it over to Patrick, I want to just kind of spend some time to talk to you about our browser phishing service. And this is a solution that provides real-time protection against target attacks, regardless of how that phishing attack was delivered, via LinkedIn, OneDrive, collaboration platforms, and other communication platforms. Browser protection, on a high level, is a lightweight, cloud-powered browser extension for all the market-leading browsers, Safari, Chrome, Edge, for example. Now, the reason why the form factor is a browser extension is that if you think about it, as a laptop or desktop user, we spend almost all of our time in a browser, right? You access your Google Workspace work account, as well as your personal email accounts using a browser, right? You share your files across OneDrive, SharePoint in a browser. And of course, you stay connected to your professional and personal networks on LinkedIn and others using a browser as well. So as a browser extension, it provides us with full visibility into your request for data, both good and bad, regardless of where you may reside. And browser extension can protect you wherever you are working from. right? Whether you're working from the office, Starbucks, or at home. So phishing, browser protection, this form factor allows us to provide that 24/7 multi-channel protection. Now, how does the protection work? As I mentioned earlier, the browser protection uses the fence-in-depth approach. The first layer is that it is consuming that intelligence that we spoke about earlier, right? Using the virtual browsers, using the machine learning, all that intelligence is pushed down through to the browser protection solution. So whenever a user attempts to access a web page, right? Clicking on a link that's in their Outlook, clicking on a link that was sent to them via LinkedIn, for example, it's going to fire up that browser, and browser phishing protectors will come in and block the user from accessing that web page. It is phishing. And the second layer of defense is that on-device ML analysis capability, right? So if this is a target attack with the URL for some reason did not make it into our intelligence network, what we will do is we'll analyze that browser canvas in real time and block the user from accessing that web page. So let me do a quick demo of this. Apologies. All right, so hopefully everyone's able to see my browser okay. So what I'm going to do is, here we go. So this is the SlashNext's browser phishing protection. And for those that are wondering, how do you deploy this? We support centralized deployment. If you have an endpoint management solution, endpoint management, UEM solution, RM solution, you can deploy browser phishing protection remotely and in scale. And once it's deployed, there's no operational cost. Everything is updated automatically without any required resources from your organization. And once it's deployed, the user is fully protected from multi-channel attacks, right? So if I go into my Twitter and click on a particular URL, it's going to see the URL that's being requested and block that request because this particular URL is in our phishing intelligence database. If I move over to Slack, right, and I click on a URL, let's click on this guy here. It obviously fires out my default browser and blocks it. And one of the unique things that we provide is what we call live training or in the moment training. So whenever we protect the user against a phishing attack, we take the opportunity to educate the user by providing them with a screenshot of the attack page that was blocked and also a description of what this particular attack is. Credential stealing is one of the oldest forms of phishing. So if your organization, and I assume almost everyone on the call, has a user awareness training program, the problem, I'm a big advocate of user awareness training programs, but the problem is users tend to forget what they have learned. So with this particular component, the live training, what we're doing is we're constantly reminding and reinforcing the behavior that we want from the users. Okay.
Yeah. So this is pretty important here, Jimmy. In that, obviously the training programs, there's a few things in those training programs. You typically train the user to look at the domain. As we have shown now, a lot of the domains are no longer, they all look good. They look like they come from SharePoint or they're OneDrive or they are Box, they're Dropbox, they're Google, or again, trusted domains. So training someone just to look at that domain, and then if it's a good domain, let it basically, you're okay, is no longer good enough. And so what we've found by doing this live reinforced training is you get a significant statistical reduction in the click-through rate into these scams and these phishing social engineering attacks. And in fact, kind of before and after deployment of the browser extension and doing this live reinforced training, you'll see it well south of 0.2% participation in these threats. So it's a very significant capability to be able to do live reinforced training that complements your user training program out there.
Speaking of trusted domains, this one is on, this belongs to a legitimate company. They provide surveys. So what I want to do, and what I have demonstrated, is the protection using the on-device intelligence database, right? What if a URL is not in our database? How do we protect users against those targeted attacks? So to demonstrate that, what I'm going to do is I'm going to open up a web page, and when I double click on this web page is going to render locally on my computer, right? Meaning that there's no URL. The URL is not in my intelligence database. So when I double click on that, what you'll notice is that you saw the credential stealing web page for about a second or two there, right? So what's happening is that when you click on a particular URL, we first track it against the on-device intelligence database. If it's not there, what we want to do is we want to allow the web page to render so that we can see the content. So when the web page finishes rendering, it essentially kicks it back to my browser phishing protection, says I'm done. All the images, tags have been fully rendered. Now scan the browser DOM to determine if it's phishing or not, right? And that's exactly what we did, and we accurately predicted using our machine learning model that it was a phishing attack. So this capability is very unique. It's a big differentiator. Whether you're looking at email security services, endpoint solutions, secure web gateways, they do not have this real-time scanning capability. And by doing it on device, there are a number of benefits, right? The first benefit is that you get lightning fast speed. I'm not proxying a user's request to my colo center, right? I'm not bottlenecking the request and the reply from that to that request. Everything is done on device, so you get lightning fast speed. Second is that we provide strong user privacy protection, right? Because again, everything is done on the user's laptop or desktop. Nothing is leaving the user's device to my colo center and coming back. Everything is analyzed by the browser phishing protection that lives on the user's device. And the third is, with the introduction of DNS over HTTPS, or DOH for short, this privacy framework, if you will, introduces a number of problems for URL filtering solutions, because you're no longer seeing the URL that's being requested by the user. So the only way to see that encrypted traffic is to have that physical presence on the user's device. Yeah. Patrick, before I turn it over to you, are there anything you want to add about browser phishing protection?
No, I think it is core, because we are asked, why do you do this in the browser, right? I think as Jimmy was highlighting here, number one, that browser is kind of your window or the gateway for that user to view all the SaaS-based apps and all those communication channels. And we do find that it's fairly unprotected. In fact, not just fairly, but significantly unprotected when these users are interacting with these different applications and certainly these different websites. So as Jimmy was highlighting, we do that lightweight browser extension, and it works with all the popular and all the popular browsers. In fact, we even support IE10 for one of our customers. So by being in that browser canvas or that browser window, we can see everything that's going on at real time, point of click, be able to detect and block those things. And second, the reason why we introduced the on-device component, as Jimmy was highlighting, there are a new class of attacks that are specifically targeted, as he was highlighting, to VIP users, or again, I get a lot of these things that they try to come after me as a CEO. But these attacks are pretty unique. And one of the latest ones we are seeing is these attacks, they don't resolve externally, they actually resolve local, meaning it's an HTML attachment to a message that may come through Discord or may come through pick your favorite type of messaging app. And that when you do the resolution, again, it resolves local to the machine, to the C drive, and with the express intent to either put something on that machine or they're trying to take something off. The only way that you can actually stop those is, again, be real time in the browser canvas beyond the encryption point, as Jimmy was highlighting, because TLS 1.3 or all, think about WhatsApp or Signal, all the other applications have their own proprietary encryption. The only way you can actually see and block these things is to be live in that canvas and see exactly as that user is seeing what's going on. And through the machine learning classifiers, we're able to detect, and this happens at 50 milliseconds or less. So we're able to detect and block that through that on-device component, those very targeted, well-crafted spear phishes that have never been seen before, and they're only targeted to you as a user. So that's the reason why we do the things in the browser. There's a couple other points that I would make. I actually came out of the proxy world, and in many respects, I always look at the ebb and flow of the compute industry. We go from centralized, decentralized, centralized, decentralized. We're kind of back in the centralized world with cloud. But effectively, we have very powerful machines. I mean, this latest iPhone 13 is perhaps more powerful than the data centers we used to have. And so in many respects, there's a lot of things we can do on that local device now that you perhaps couldn't have done before. So we can do things local and take advantage of very high speed performance. As I was mentioning in the on-device component, we do it at 50 milliseconds or less. So what does that mean? I am not proxying every time I have never seen a particular page. I'm not proxying that back to some data center or some cloud to go make a decision. I as a user won't tolerate that if it takes 1 minute, 2 minutes, 5 minutes. And this is in many respects, and I know I'll use one kind of funny term here. I say friends don't let friends browser isolate because you don't want to proxy these requests back to some central location to make a decision and then bring it back. So we do this stuff on device. We have the best detection capability because we see real time what's going on. And we do that through that two-phase detection. One, the database that sits there, which right now will source between 2 to 3x greater even than Google, what the 0-hour attacks are. Google Safe Browsing has somewhat been that industry benchmark out there. And we had the pleasure to work with those guys and showed how they even missed 50,000 hosted attacks in their own properties over a 30-day period. So that uses that database, and also uses that on-device component. So you have great detection, but second, you have screaming performance because it is local. Everything executes local. You're not having to, again, proxy things back. This is not a proxy solution. Third, by also being on device, if you also think of the world today, there's a lot of BYOD. There's also, let's call a spade. A lot of times the users don't want to know that you're looking at their browsing history, browsing behavior, et cetera. By being on device, we can also guarantee privacy. In fact, we never share browser history, browser kind of usage back to a central location. So that allows you to use BYOD and allows you to use, again, even when you're not doing BYOD, they're company issued. There's a trust factor you can gain with your employees. And finally, by using that browser extension, and I should note the same thing in the mobile device. We support the mobile. Our mobile app works in iOS and Android. It has the added benefit of using SMS, as Jimmy was highlighting, natural language SMS detection and blocking. But once, as Jimmy was highlighting, it's deployed and it's deployed at scale using Intune or AirWatch and a number of the tools out there. It is truly a set and forget service. So there's immediate benefit once it's put out there. It's all automated. So it is a SaaS-based service. And once it's put out there, again, all updates happen automatically. We're not like your old McAfee EPO environment where when you do an update, it takes, basically your machine feels like it's going to burn up. We do 10-minute updates or refresh rates because we are constantly seeing new attacks. We also auto-retire those threats that have come off. But those updates are about 2K. And so they're very, very lightweight. And that means that, again, it can be extremely efficient. And then that same thing happens on the software updates, extremely lightweight. So you never have to actually administrate what's going on here. And in fact, on that administrative side, you're not maintaining whitelists. You're not heavily going in and trying to, hey, let's figure out what the latest attacks are. And if it wasn't seen here, let's go block it on the other side. So that's the advantage, again, of being on the browser. And it really does give a unique capability to, what I like to say, protect the unprotected, because that browser is that new OS. It is that new gateway to the world. And candidly, it really is unprotected for what users are going out and looking at. So, Jimmy, can we, I know we only have about 3 minutes, so maybe we can just close here. So just to close, we, as Jimmy was highlighting, have a defense in depth service. It really is built off that technology foundation, that architectural foundation that Jimmy highlighted, with what that threat cloud and how we're sourcing the threats, and creating that database of 0-hour attacks. Right now, we're sourcing between 25 to 50,000 new 0-hour attacks daily. Again, as I said, that's about 2 to 3x greater than anyone on the planet. That intelligence is made available down from a protection side in the browser extension, the mobile app. But there's other key things that we believe are important to also offer as part of the defense in depth service. So second, not only do we do the protection, we do the live reinforced training, as Jimmy showed. So if it's an account takeover, we want to educate the user and say why it was, why we're actually blocking the page. Third, the defense in depth service includes a baseline assessment. So you always want to continually know what your current tools are doing. What got through Proofpoint or Mimecast, what got through ATP Defender. Also, what are your users interacting with weblog? So we have the capability to basically plug right into the Microsoft Graph API, Office Microsoft 365, and continually give you an understanding of what's getting through those current systems. And then finally, as they like to say, sometimes stuff does get through, sometimes stuff does happen. So how do you respond to those incidents? So we have a very well-formed instant response mechanism as part of the service. We integrate with the popular SIMs and the SOARs. And in the SOAR case, something like Palo Alto XSOAR or Swimlane, we have the capability to do automated abuse inbox, but we also have the capability to do reputation protection in the playbook. And in fact, we won Playbooks of the Year last year with Palo Alto. So again, very well formed instant response. And so not only can you do the automated abuse inbox reputation protection, as I said, but you can also do threat research and threat hunting. We will give you all the metadata fields. I think, Jimmy, it's 14 metadata fields, right? So you get the picture of the threat, when it was first seen, last seen, et cetera. So bottom line, this defense in depth service gives full protection against these very significant threats for your users, and really an opportunity to augment as a new layer on top of your other layers of security. Any good security posture is a multi-layered security posture. So an opportunity to layer this in to do this detection and blocking. And finally, I just note, Jimmy, if you go to the next slide, kind of like to say we take the challenge, right? In many respects, it's only as good as you see how good it is. So number one, really we have that, again, that live assessment. It is complimentary. So you have the ability to go into Microsoft 365 as well as Google Workspace and see what got through your current defense and your current email security. Now, remember, that's only one channel of communication, but it's a very important channel. This gives a good insight of, again, what got through Mimecast, Proofpoint, what got through ATP Defender in those different environments, what got through Google security. It can be pretty eye-opening when you see these threats that are just sitting there waiting to be, interacted with. Second, I would highly encourage, we have a complimentary trial that you can do. Again, deploy the browser extension. That's the best way to get to see what threats get blocked and what your users are interacting with. That literally takes, you sign up for an account, it takes about 5 minutes, and you can deploy something. And within that context, you can see how it interacts and moves forward. And if you just want to even just check out a particular URL, or is it a threat or not, we have right on the website a quick and easy way at the top of the main page to put in that URL, and you can get a verdict. Is it a threat or not? So bottom line, we really want to encourage just easy use, easy testing of the system. It is all self-service. You don't have to talk to a salesperson. This gives that opportunity to interact with the different folks. So I think we have, again, about 1 minute here. So actually we're a little bit over. Any questions, Lisa?
You answered all the questions brilliantly through the presentation.
Okay,
so yeah, I think we're good.
Yeah, good. Yeah, again, I know we're a couple minutes over. I do appreciate everyone joining us today. And the only other thing I would say, we do a webinar series called Fish Stories, where we go through some of the latest threats that are seen out there. And the next one we will have is on the on December, what is it, December 14th. And the next one, just as a preview, it'll actually talk about, again, the association of phishing and ransomware. It truly, ransomware is, a board level discussion. But as I previewed before, and as we've seen statistically and through the data, the ransomware starts with the human element. And again, just as that preview, if you do that, go read, everyone should do yourself a favor, go read the Microsoft synopsis on the Colonial Pipeline attack. Just quick, short, abbreviated version. It was a human interaction that caused an account takeover. They gave up their credentials. They got client VPN access, and then they laid in the ransomware. That's very, very typical. So that we're going to go through some of those examples again and dive deep into exactly what's going on in terms of kind of that phishing and ransomware element. So I appreciate everyone's time. Thank you, Jimmy, for going through the technology deep dive. And if you have any questions as a follow-on, please feel free to reach out to us. And thank you for joining us today.
Thank you, everyone.